Hey everybody, this is Todd Frazee and this is the tutorial for the locating button. But we're also going to go over thread planning. On these three projects that we have for Unit 9, I am editing videos that were originally published by Allison Salome. So please go through the thread planning that I'm going to do here first, and we're gonna plan out the threads for all three jobs in this segment. Okay, so this is the locating button, and it's on page 944 of your Technical Graphics Communications book in figure 19.58. And so we want to record some information before we start modeling, because we need that information to model the threads properly. So we've created this thread planning Excel sheet, and if you bring it up, it'll have several fields you'll need. And some of this information is more information you need to do the call out, but you're going to need it for modeling purposes. So in this first line, let's put the description as the locating button. And if we go to our drawing the locating button on page 944, it's calling out a nominal thread size of a number 10, which is a wire size. So we're going to go back to our Excel sheet, and that's going to go into your nominal size. So it's a number 10. Now, Allison in her lecture notes that you never use nominal sizes on a technical drawing. And so she has you convert this into a decimal point number. I'd strongly disagree with that. I've got over 25 years of experience, and only military standards calls out a number 10 screw as a decimal. So the way she has you do this project, it'd be correct if it was a military drawing, but everywhere else in industry, you're going to call that a 1032 screw. Okay, so we know from our drawing that the thread pitch is 32. So we'll go ahead and skip over to the thread pitch. That means there's 32 threads in a span of 1 inch. Okay, and the standard according to the drawing is UNF. UNF. That stands for United National Fine. And it doesn't denote a class. And the form, A is a external thread and B is an internal thread. So this would be a form A, being a screw. And our length is 3/4 of an inch. So that's the length of the actual thread. Might not be the length of the bolt necessarily, but our drawing has 3/4 of an inch. So 0.750. All right, so now we need to reference a chart for the minor and major diameter. So let's go back to Canvas. So you're going to go to the screw threads handout and click on that. And this is out of the Machinery's Handbook, the source data for this. Excellent book. If you plan on going into mechanical design, I recommend you buy one. Condenses a lot of the standards. But we're looking for what? A UNF thread. So this is a UNC, which is UNC course, national course. So we're going to go down to the next chart, which is UNF. Should be table 5, fine threads. We're looking for a number 10 diameter. That's a nominal size of 190 thousandths. You're looking for a couple numbers. You want your basic major diameter, which on a number 10 screw is going to be this number I've highlighted. So let's go to our chart, and we're going to put in 0.190 is our major diameter, 190 thousandths is the major diameter. And now we need to go look at our chart for the minor diameter. So we're going to go over here and we're doing an external thread. And we cross-reference over. And it's 152 thousandths 8 tenths. So 0.1528. Is our minor diameter. So this is the crest of your thread, and this is the root of the thread on an external thread. And our form is an A thread. The thread class, sometimes you don't call it out, but it has to do with the tolerance that the thread has to be held to. Let's move on to the next part we're going to be making. And the next part we're going to be making is the knurled head screw. So we want to look at its call out, and it calls out a 0.31-18 UNC by 1.5. So let's go back to our chart and let's fill out as much as we can. We have the knurl head screw. And its nominal diameter is 0.31. And our thread pitch is 18 threads per inch. We know that from the drawing. And that's a UNC thread. And we're doing an A thread again. And the length is 1.5 inches. Now you notice the drawing has the shaft is actually 1 3/4. So that means that there's a shoulder where there isn't any thread on the bolt. It's not a fully threaded bolt. Okay, moving on, we're going to find out what the major and minor diameter of this particular screw. So we're going to go back to our screw threads. So we need to go to the UNC chart. And what they're calling out as a 0.31 is actually a 5/16. So the nominal size is actually 0.3125. So if we were to do this to the chart, or to the sketch drawing, and this was a military screw sold in the military, you would call it out as a 0.31. If you were to go down to the hardware store, it'd be a 5/16 18 screw. Okay, so our basic major diameter is actually 0.3125. And we're going to have a minor diameter, which is an external thread. And that's going to be 0.2464. Okay, so we have our information for the knurled head screw. For posterity, we're going to make these class 2 threads. It'll be a pretty typical thread class. Our third part. So we're going to go to our third part. We're going to go ahead and plan for that one as well. And our third part is this end cap. And it's calling out a 1/8 UNC thread, so that's 1 inch. And it's calling out a 2A thread class. And it doesn't tell you the length of the thread other than the dimension. So according to the drawing, the overall part is 1.6 inches long. And we're going to subtract 0.73, which gives us a thread length of 0.87. So that's how long the thread is. So let's go fill out our chart with the information we have. The nominal size is 1 inch. Okay, and the major diameter, we'll get that from the chart, and this is for the end cap. And that's 8 threads per inch. UNC for coarse. Class 2, it's an external thread, so it's A. And we calculated our thread length as 0.87. Alright, so we'll go back to our handy dandy chart, screw threads. And we are on the course again. So we're going to be looking for a 1 inch. So 1 inch has a major diameter of 1 inch. And so we'll put that in. And a minor diameter of an external thread, 1 inch, gives us a minor diameter of 0.8512. Okay, so you're going to want to save this. I'm going to go ahead and change this to 5/16 of an inch because that's what it is. And this is 1 inch. That's what its nominal size would be. So we have all the data we need, and we can keep referencing for all 3 projects. Okay, now we'll proceed, and Allison will take you the rest of the way on this project.
Okay, guys, so we're back. This is the section for AutoCAD, and I was able to capture my images from the iPad and send them over to the computer so that we can toggle back and forth between the notes we made on the whiteboard or in your notes and what we're going to work on AutoCAD. So here's our problem, and here's the data that we collected for developing this problem. And we're going to develop simplified screw threads here. So I'm probably going to do this in 3 videos, one for simplified, one for schematic, and one for detailed. But here's what I'm not going to do. I'm not going to spend time in AutoCAD drawing lines for you. You guys should be pretty good at that by now. So I'm going to kick over to AutoCAD. And basically what I'm going to do here is it won't let me show both apps on the screen at the same time. So I'm going to be working over here in AutoCAD. I have my notes alongside so that I can see them. And we're going to work through the information on this problem together. So as I said, I'm not going to be teaching you how to draw lines. Now, this is an exclusively 2-dimensional AutoCAD drawing. It is not a 3D CAD drawing, okay? So we're not 3D modeling. We're drawing our views. They're all being drawn in model space. Geometry always goes in model space at full scale. And you're going to develop the views alongside each other as if you were sketching on paper, making sure those views are in the correct locations according to Glassbox, and making sure that they're aligned with each other. So what I did is I started my drawing. I used the geometry that I had and drew up the end view of my locating button screw and the profile view or front view of my screw here. And now what I'm going to do is I'm going to draw in the body of the screw and show you how to do simplified threads. Okay, so assuming that I have developed this correctly and used the correct diameter for my major diameter here and the correct diameter for my minor diameter here, I'm going to simply use that data to move it over to the other view. So on the profile visible lines layer, I'm simply going to take a line from this intersection to the perpendicular of there, and a line from this intersection to the perpendicular of there. Okay, now the length of the body of the screw is 0.750, so I'm going to offset that. So that would be the end of my screw. And I'm going to clean that up. Okay, and then we need to know where the minor diameter is. So on the hidden lines layer, I'm just going to take a line from here to the, again, perpendicular of here, and from this intersection to the perpendicular of there. And what these lines represent is these lines represent the white visible lines are the major diameter, and the hidden lines are the minor diameter. And I'm going to trim to there, take out that, take out that. Okay. So that's a simplified screw thread. It doesn't get any easier than that. That's the easiest kind of screw threads that we can show on a drawing. They are allowed per ASME. And they tell the viewer between looking at this, knowing that, hey, that hidden line there is something, and this, that is a tapped hole. Now, think about why that makes sense. If I'm looking at the end of a screw, the object line that I see is at the crest of the screw thread. And what's hidden from me is the cut, V cut down to the minor diameter or the root. So if that were a hole going through this part, this would appear as a solid visible line. But because it's hidden from my view, it indicates that along with this data over here, that is indeed screw thread representation. Now, of course, you're going to have to call that out. You're going to have to do that with a thread call out. I set this up on an A size single view layout. And I used a scale of 4:1, worked great. I am going to bring my dimensions on, which I started. I'm not going to show them all to you because showing you the entire solution on screen where you can pause and duplicate it, not cool. But what I do want to do is I want to talk about how I put in the thread callout. So I'm going to unfreeze my dimension layer here. And so I want to talk about the thread callout. So in this case, the thread callout is being pulled off on a leader. It is a single line of information, 0.190-32 space UNF-2A, as we discussed in our planning sketch over there on our whiteboard. And so I want to show you how to do this in AutoCAD. So AutoCAD has two different commands for doing leaders. Actually, it has more than two, but we're going to talk about two of them. It has the leader command, which you must type in, and it has a command called multi-leader, okay? And that appears over here on my annotate sheet in a panel called leaders, okay? So this panel called leaders, everything that happens in this panel is a multi-leader. Now, multi-leaders are great if I'm an architect. Multi-leaders are great if I'm doing civil drafting. Multi-leaders are a pain in the butt if I'm doing mechanical. And here's the reason why. A multi-leader requires an entire setup for a style to manage it. So, in other words, if I just use a multi-leader, don't do this, but if I did, if I just used a multi-leader here and pulled this out, take my ortho off, and typed in my information, 0.190 dash, am I in paper? No, I'm not in paper space. 32 space UNF dash 2A. And I enter, Oh, I got to tell it I'm done. Close text editor. That's what I'm going to get. Because multi-leader requires you to do an entire style setup for how you want it to appear. Okay? So I'm not using multi-leader. And I'm telling you, don't use multi-leader. Here's why. The leader command, which we're going to type in at the command line, uses all of the settings that are currently set in your dimension style. So think about that. I can set up one dimension style, and if I use the leader tool, all of the settings for that leader are going to match my dimension settings. Or I can use the multi-leader where it doesn't match, and I've got to go set up a style and try to make that style match what I did in my dimension. It doesn't make sense for mechanical because we always want our leaders to match the dimensions. So the way I did this is I used the leader command, and you've got to type it in at the command line. It's Leader. Okay? And it asked me for the start point, and you can start anywhere here. You can grab the midpoint. Make sure it is grabbing onto your major diameter, and you're going to pull it off. Now, initially, it's going to look like it's doing the same thing that that other tool did, but be patient with me here. It asks me to pick the other end of my leader, so I'm going to pick, and then I've got to turn ortho on, and I've got to draw that shoulder in. Now, when I'm done drawing the shoulder, it lets me continue drawing landings. Now, I've never seen a mechanical that had more than one landing, so I don't want that. I'm actually done drawing the line portion. And if we look down here on the command line, it says if I hit the enter button, it's going to jump to annotation, and that's what I want. So I'm going to enter. And now notice my command line, it's prompting me to enter the first line of the annotation text. So 0.190-32 space UNF-2A. And how do we tell AutoCAD we're done? We enter. How do we tell AutoCAD we're done? Enter. And so you're going to see that this text matches my dimension text. The arrow size matches my arrow size. And I've got a coherent leader that follows with what I've already set up and conforms to my ASME standard. So that's how I do those leaders. Make sure that you have your views all. Make sure you pay attention to line weights. Make sure that you have your views lined up. We did upload onto Canvas for you your ASME drawing guide. You don't have to submit those to me. But let me tell you, if I'm marking up a million things on your drawing, I'm going to be cranky and I'm going to be nagging you to use that checklist. So make sure you use a checklist for every drawing for yourself, which is a really good thing to do because we don't really have an opportunity to sit and talk about these together much. So to get the best scores, make sure you're going through those checklists, checking things off, making sure you're reading through and looking at those drawings before you submit them. Okay, this is going to be the first one. This is going to be the locating button video. So take a notes and let us know if you're having any CAD problems. If you're having crashing and freezing, etc., make sure you email Patrick and try to get him to help you maybe adjust settings to maximize how AutoCAD is running on your machine. Okay, guys, I'll see you in a few minutes on the other part.